This lesson is about the electrical multimeter parts in operation. So you learn the basic parts in operation of this particular multimeter. You learn how to measure voltage, also how to measure resistance. You learn how to check for damaged wire or components, which is called continuity. You identify the settings of the multimeter dial. In addition to this lesson, you learn how to read the resistance of a resistor using color-coded bands. So this multimeter operates with a 9-volt battery and can support up to 500 voltage and a maximum current of 10 amps. So let's get familiar with this multimeter. So here we have 4 basic parts. The display, where the measurements are displayed. The selection knob or dial. This selects what you want to measure. You want to measure voltage, current, or resistance. We have 3 ports. This is where you are going to plug the probes. And we have one set of 2 probes. One is red and the other one is black. So this is one terminal and this is the other terminal, and vice versa. So how to connect the probes? The black probe connects to the COM port. COM, C-O-M, stands for common. The red color probe connects to the voltage resistance milliamps probe or to the 10 amps probe. Important notes. Only move the red probe. Never unplug the black probe. Keep red probe on the voltage omega milliamps port if you are measuring voltage resistance and or small currents. Move the red probe to the 10 amps maximum if you are measuring higher current over 1 amp. Measuring voltage. You can measure DC voltage or AC voltage using this multimeter. The DC voltage is indicated by a straight line or by the V sign. Usually we use the direct current voltage to measure voltage of batteries, for example. And the AC voltage is indicated by this wavy line, by the V sign. The range for the DC goes from 200 millivolts up to 500 volts. Notice that we are using the prefix M, which is for milli or 10 to the negative 3. So in this case, 200 millivolts is 200 times 10 to the negative 3, which is 0.2 volts. So here 500 does not have any prefix, so 500 volts. For this class, always keep the voltage set on 20 volts. The AC range goes from 200 volts up to 500 volts. We are not using this option in this class. but I just want to indicate that is an option for alternating current to measure the voltage. Now let's take a look on the resistance range. So this side is the resistance. We can be indicated by the omega symbol. So it ranges from 200 ohms up to 200 mega ohms. So notice that here in this section we have two prefixes. We have K, which is for kilo, which is 10 to the positive 3, and we have mega, which is also a prefix that is 10 to the positive 6. So before select the proper dial, you need to read a resistor to select how will be the best option to measure the resistance using a multimeter. Measuring a battery voltage steps. First, use the dial and select 20 on the DC voltage section. Then connect the black probe with the negative side, and then connect the red probe to the positive side. What happens if you switch the red and black probe? So in this case is indicating 1.59 volts. So now we are going to switch the probes. And we are not going to observe anything major happen. Nothing dangerous. The battery will not explode. The multimeter will indicate a voltage. However, this voltage is negative. This is because the battery is polarized. So it's required to use the proper connection to the battery terminals. Measuring resistance steps. First, keep probes on the correct ports. Read the resistor code and determine the resistance. I'm going to teach you how to read a resistor in a few minutes. Select the appropriate scale. So it's a good practice to read first the resistor using the color code. Once you have the value, then you can select the proper scale on the dial. Then connect the probes to the resistor leads. So resistors are not polarized like a battery. The way you connect the probes doesn't matter. The result is the same. So for example, here we have this resistor with those bands. So here is gold, which is the tolerance, and you are going to read, this is your first band. 1, the first figure, the second figure, the number of zeros, and the tolerance. So this resistor is 15 ohms with a tolerance of plus minus 5% because we have a gold band right here. So what the tolerance means is that the value of this resistor is going to range from 0.75 ohms. So we're going to add 0.75. So how I got this number? You just need to find 5% of 15. So 5% of 15 is 0.75 ohms. So plus minus means that you are going to add this 5%, which is 0.75 ohms, to the actual value, which is 15 ohms. So by doing that, the value of this resistor can go up to 15.75 ohms. Likewise, you can subtract 0.75 ohms from the value of this resistor, And the minimum value for this one is 14.25 ohms. Now, when we measure in the using multimeter, select the dial of 200 ohms, which is the lowest one. So it's important to know about how much is that resistor and the resistance of this resistor to select on the dial the proper value. In this case, that is nothing less than 200 ohms. So that will be my option meter. Since this number is between this range, this is a correct value, 14.8 ohms. So the meter indicates 14.8 ohms. Checking continuity. Most multimeters provide a feature that allows you to test the continuity of your circuit. Use this feature only if you want to check damaged wires or if 2 points of the circuit are not connected. To use this functionality, you are going to select the mode that looks like a speaker. How does continuity works? If you do not hear a sound, it means that there is a loose connection that prevents the current to flow. Check each component of your circuit and make the corrections. Warning: to test continuity, you should turn off the system. Disconnect the battery. Then you touch the two probes together and you hear a sound. To test the continuity of a wire, you just need to connect each probe to the wire tips. If the wire is in a good condition, not damaged, you should hear a sound. I used the continuity feature to test if each fuse was burned or open. So this meter is not working properly. So I open up the meter and here we have two fuses. They are ceramic. The reason why they are ceramic fuse is to dissipate the heat and protect the components in the surrounding and also the casing of this multimeter. So because it's ceramic, I cannot see the filament inside the fuse if it's open or not. So I can use the continuity feature to test if there is a fault or an open circuit right here because the meter is providing a 9-volt batteries for this circuit. So I heard the sound, which means that the fuse is in a good condition. This is the fuse for the milliamps, and this is the fuse for the 10 amps. Now, you are going to learn how to read a resistor bands. So we are going to use this to compare with the reading with your multimeter. So here is an example. We have this resistor with 1, 2, 3, 4 bands. The way that you read this is place the resistor in a horizontal position and that face to you, and make sure that the shiny part, which sometimes is gold or silver band, is on your right. And then you are going to start with the first band. So the first band is the first number. The second band is the second number. The third band is the number of zeros. And the shiny band that can be silver or silver or gold is the tolerance. So in this example, we have here red, and then we are going to connect red with the number. So red is 2. So the first number is 2. The second number is, this is violet, is 7. The third band is the number of zeros. So this is orange. Orange is 3. So I have 3 zeros. And the last band is the tolerance. In this case, it's silver. So silver is plus minus 10%. So this resistor value is 27,000 ohms, plus minus 10%. So we can simplify by using, instead of those 3 zeros, the corresponding prefix, which is kilo. So 27 kilo ohms plus minus 10%. Okay, so we are going to do this practice problem. So we have here the codes and we have the resistors. So notice that some resistors, they are not aligned properly. So you need to read from left to right, but make sure the right is the shiny part, gold or silver. So in this case, this resistor A is correctly placed. So the first band is yellow, which is 4. The second band is violet, which is 7. So 4, 7. The third band is red, which means the number of zeros, 4, 0, 4, 7, 3 zeros. And the last band is the tolerance, which is plus minus 5%. So for A, we have 47,000 ohms, plus minus 5%, because it's gold. And we can simplify as 47 kilo ohms. So we repeat the same thing for the resistor B, but in this case, the resistor B is flipped. So you need to read this first band here. So the first one is red, which is 2. The second one is also red, which is 2. So 2, 2. The third band is the number of zeros. So 2, 2, 2 zeros, and plus minus 5%. So that is 2,200 ohms or 2.2 kilo ohms. So C is also flipped, and D is in the right position, F is flipped. So you need to be careful when you see, you need to find first the shiny one or the tolerance in order to read the resistor. So here I have the results for you, but please try first and then compare with my results. Lastly, I want that you make a diagram about all the parts of this meter. I did not talk about those two options, but it's very simple. Hold. So let's say that you are measuring and your display is kind of changing constantly the number, like 3.2, 3.1, 3.0, and you want to first make sure that if you are holding something to measure, make sure that you stay still. So avoid this fluctuation, but then you have actually to stop this, so you press on hold and you're going to freeze the display and you can record your number. Now this blue key is a light, so if you are in a darker room, and especially if you are using this multimeter for like going to an attic and there is not that much light and you want to see what the display is showing, so this is a very good option. You press on this and the display light up. So I think we cover everything, and the only thing that I need that you do now is make a diagram with all the parts of this multimeter, and should look like this. So the display and options for the voltage, options for the AC, current, resistance, and here we have the ports that how you are going to connect.